Hi everyone, this is the part 4 of reviewing for test 1. I start by the piecewise function. Here we have f of x. For x less than 1 is negative x plus 3, and for x greater than or equals to 1 it's 4x minus 2. Domain of this function is here. So if this is the number line, x can be less than 1 or x can be 1 and greater than 1. So basically it's all real number. Again, one part is for all x value less than 1 and another statement is for 1 and greater than 1. So from negative infinity to positive infinity consists all real number. Now, how we can draw graph of function and how we can find the value of function. For example, how we can find the value of function for 0. To find value of function for 0, we need to check that 0 is less than 1 or greater than 1. We know that 0 is less than 1, so we need to use this statement. F of x is negative x plus 3. It means that f of 0 is negative times 0 plus 3, so it's 3. We have point 0 and 3. To find f of 1, again we check if 1 is less than 1. No. Can I say 1 is greater than 1 or equals to 1? Yes. So we need to use this statement. F of 1 is 4 times 1 minus 2. So it's equals to 2. And we have the point 1 and 2 on the graph of function. What is f of 2? Again, 2 is greater than 1 and I need to use the statement for x minus 2. 4 times 2 minus 2. So it's 8 minus 2, 6. We have the point 2 and 6 on the graph of function. And similarly, f of negative 1, because negative 1 is less than 1, we use this statement. So it's negative times negative 1 plus 3, and it's equals to positive 4, and we have the point negative 1 and positive 4 on the graph of function. Now let's sketch the graph of function. To sketch the graph of function, I need x and y-axis. Okay, this is x and this is y-axis. Here we have piecewise function. It means the function has two statements here. For all x less than 1, f of x is negative x plus 3. This is a line. Why? Because the exponent of x is 1 and also the exponent of y is 1. So this is a linear function. We know that we are able to sketch the graph of linear function with just 2 points on the graph of function. X can be less than 1. So I can use 0 and 3, negative 1 and 4 to sketch the line. So this is negative 1. Here's 4 and 0 and 3. 1 point is here and another point is -1 and 4, this point. And now we can sketch the line. The line starts right before 1. X can be anything less than 1. So it doesn't start from 0 and goes to the negative. Actually, it starts from 1 and then goes up. But 1 is not included. It means there is a hole here. There is a hole here. So what is the value of, if I plug 1 here, I'm not able to plug 1 here actually, but let's suppose that I plug 1. If 1 was acceptable, the answer for y value was -1 plus 3, it was 2. So 1 and 2, this point was on the graph of function, but right now there is a hole here. So just know that there is a hole here and we have this line. Okay? This is one part of this piecewise function. For x less than 1, and as you see there is a hole here and point 1 and 2, it's not included. Now there is another segment for this function. For x equals 1 and greater than 1, and again this part also is a linear function because the exponent of x is 1, exponent of y or f of x is 1. And again we can sketch a line with just 2 points on the graph. Okay, the point 1 and 2 is acceptable because x is 1, and also the point 2 and 6 is acceptable because 2 is greater than 1. So I pick these 2 points. First 1 and 2, which is here, and now I fill the hole because 1 and 2 is on the graph of function right now. And another point is 2 and 6. This is 2 and here is 6. So I have this point. And now there is another part, this one. As you see, the function has 2 sides. From this one goes to positive infinity, from this side also goes to positive infinity. This point belongs to the function because although at the first it was a hole, because 1 and 2 were not included, 1 wasn't included in the domain here, but later on we recognize that the point 1 and 2, it's in this segment as well. So we filled the hole, and now this segment for x greater than 1. As you see, domain is from negative infinity to positive infinity. Range of function starts from 2, goes to positive infinity. And this point is the minimum point for the function. It can be absolute minimum and also local minimum at the same time, because in this interval it's minimum, and for the entire domain of function this point has the lowest y value. It is obvious that this graph, it's not symmetric with respect to origin or y-axis, so it's not even or it's not odd. And if you move on the graph of function in the positive direction of x-axis, you see that the graph is decreasing from negative infinity to 1, and then it's increasing. So in this part, it's decreasing from negative infinity to x equals 1, and from x equals 1 to positive infinity, it's increasing. There is no x-intercept for this function. It means there is no zero, no real root for this function, and there is only one y-intercept at point 0 and 3. In the next question, we want to factor the expression. The first step is to see how many terms are in the expression. There are two terms. One of them is the square of 3x minus 5, and the other one is x times 4 times 3x minus 5 times 3. One term and one term. Now, what is a common factor between these two terms? It's obvious that 3x minus 5 is a common factor. So let's factor 3x minus 5. When we factor 3x minus 5, actually from the first term, which is 3x square of 3x minus 5, we divide it by 3x minus 5 to factor it. And also, we divide the second term by the common factor, which is 3x minus 5. I want to do all the steps. When we divide, then we simplify. Here I divide numerator and denominator by 3x minus 5. So I simplify this way. What is the remaining part? It's 3x minus 5. And then from the first term here, the remaining is 1 3x minus 5. And from the second term, 4 times x times 3. 3 times 4 is 12. So we have 12x. Now let's simplify whatever is inside the square bracket. We have 3x plus 12x, it's 15x minus 5. Is there any common factor between 15x and negative 5? Yes. 15 is 3 times 5. So here, actually, I have 3 times 5 times x, and here I have 5. 5 is the common factor. So let's factor out 5. So I have 3x minus 5. In the square bracket, I'm going to factor 5. It means that I'm going to divide each term by 5. 15x divided by 5, it's 3x. Negative 5 divide by common factor, which is 5, it's negative 1. Is there any common factor? No. Can I simplify more? No. And you see that it's completely factored right now. 5 times 3x minus 5 times 3x minus 1. Now let's factor this trinomial completely. Here we have 12q squared minus 7q minus 10. If there wasn't 12 here, probably I was looking for two constant. Their multiplication is negative 10 and their addition gives me negative 7. But right now we have 12 as a coefficient for q squared. What should we do in this case? We want to factor by grouping. The first step is to multiply 12 by negative 10. 12 times negative 10 gives us negative 20. Now we are looking for a times b, negative 120, and a plus b, negative 7. There are a bunch of possibilities for a and b, but a times b should be negative 120, and at the same time a plus b, negative 7. For example, negative 1 times 120, or positive 1 times negative 120, 2 times negative 60, or negative 2 times 60, 3 times negative 40, or negative 3 times 40. But just one option has the multiplication negative 120 and their addition negative 7. If you check all the possibilities, you see that those values are negative 15 and positive 8. Now I'm going to rewrite this equation. Instead of negative 7q, I'm going to replace negative 7q by negative 15q plus 8q. So let's rewrite the statement. We have 12q squared plus 8q minus 15q minus 10. And now I'm going to factor out by grouping. These two terms are instead of negative 7q. The first group is 12q squared plus 8q, and second group is negative 15q minus 10. Now between these two groups, we want to factor the common factor from the first and then second group. Between 12q squared and positive 8q, the common factor is 4q. Because 12 is 3 times 4 and 8 is 2 times 4. So the first common factor is 4. And between q squared and q to the power 1, it's the common factor. 12 divided by 4 results in 3, and q squared divided by q results in q. And if we divide 8q by common factor 4q, the remaining part is positive 2. From the second group, what's the common factor? Negative 15 is negative 5 times 3, and negative 10, it's negative 5 times 2. So the common factor is negative 5. So we factor negative 5 from negative 15q. The remaining, when you divide, is positive 3 times q. And from the second one, divide negative 10 by negative 5. Remaining is positive 2. Now you see that there is a common factor between the first and second term. So we factor 3q plus 2 from these two terms. If we factor 3q minus plus 2 from the first, the remaining part is 4q. And if we factor out 3q plus 2 from the second term, the remaining part is negative 5. And now you see that we factored 12q squared minus 7q minus 10 completely, and it's not possible to factor more. Okay, that's all about reviewing for test 1. I hope now you are more prepared for the test, and good luck.